do is go back over things I've done in the past and see how they kind of panned out. So that's why the first thing here is I'm going to do a little reprise on my talk a couple of years ago about Bayes', last year about Bayes' rule and Mr. Rossi, to see how that worked out. See where we are with cold fusion. And then I've got some ideas about the... you ready?
Yes.
Okay, and then I've got some ideas about the singularity. Woo! So, cold fusion. So I did this calculation, which is basically around Bayes' theorem. Hands up anyone who doesn't know Bayes' theorem. Okay. So it's basically a way of taking your preconceived view of the likelihood of something, taking into account some new evidence, and then updating your view about what the probability of that thing being true is. So, the thing about Bayes' theorem is that it allows you to sort of continually update your view about where you are. The criticism that people often make of it is that it requires you to have a preconceived view to start with, a so-called prior probability. So in this case I did, now who hasn't heard about cold fusion and the ECAT and Mr. Rossi, etc. So this character, Mr. Rossi, who has a somewhat checkered past, a few decades ago he claimed that he had a way of recycling industrial waste and turning it into energy and fertiliser or something, and he ended up being prosecuted for dumping waste. So he has a somewhat checkered past, but he claims to have come up with this machine called the ECAT, which utilises cold fusion and will therefore produce basically unlimited supplies of energy for us, which if true would be fantastic. So I applied Bayes' theorem, and basically what Bayes' theorem does is you start with the prior probability of someone having come up with a radical new energy source, which if you look back in history, there's maybe one or two new radical energy sources per century. So in the last 100 years, possibly nuclear fission, and you might argue that photovoltaics are a new form of energy, although you could also say it's just a new form of solar energy, and solar energy's been around for a long time. So 1 to 2. So let's say 1. So I'm saying here the probability of someone's actually come up with a new energy source in a given year is 1%. One genuinely new energy source every 100 years. Then we multiply that out by the probability if someone has a new energy source that they will claim that they have a new energy source. Why wouldn't you? Maybe if you say the American military came up with one, they'd keep it secret, who knows? So I put it probably 90%. Then we divide this by a more complicated expression, which is basically what we've got here is the probability someone's come up with a new energy source by the probability that they'll announce it, which is the same thing here, plus the probability that someone doesn't have a new energy source, which is 99%, by the probability that someone will claim to have a new energy source. So you do all that math. I don't expect you to understand all that, but basically it comes out with the fact that someone's claimed there's a new energy source still only means it's quite unlikely, because it doesn't come along very often and you need strong evidence. If something's inherently unlikely, you need strong evidence to convince yourself that it's actually true. So I came up with an estimate of 2% that Rossi was actually on the level. So my perception, I just got an email earlier today saying that Rossi has announced yet again that he's about to do a public demonstration of his ECAT. But no, to my mind, no unequivocal evidence has shown up that he's actually achieved it. He got some scientists in and they observed his thing going, but there were various loopholes and so forth. So my perception is cold fusion has not happened to this stage. So To my mind, this sort of low estimate has probably panned out. I don't know what you guys think, if anyone has a more optimistic view about cold fusion and where we're up to than I do. No contradiction? No, I'll be aware of that in the future. Okay, so that's cold fusion. So I think my basis theorem, I think, has stood up pretty well.
Grab a chair. Just grab a chair. Just grab a chair.
Okay, so much for Mr. Rossi. One of the pitfalls of Bayes' theorem is it doesn't work very well in very complicated situations. It becomes computationally intractable. But there's actually, I think Udacity has a course about it, about probabilistic graphic networks. If you want to learn all about that. And there's, it's on Wikipedia, etc. But it produces very unintuitive results, but probably better than what you come up with just by sort of gut feel. We're not very good probability calculating machines. Okay, so let's talk about singularity. So just in brief, the technological singularity basically is the concept that if Moore's laws continues, even if it slows down somewhat, in a few decades, computers will have more computing power than the human brain. Therefore, it's likely they'll have greater intelligence than us, and the future therefore becomes entirely unpredictable. Just as, say, ape-like creatures 3.5 million years ago could have had no idea what would happen with human civilization with the advent of our brains, which are sort of 5 times their size. So then, in a nutshell, that's a singularity. If you look at, say, Moore's law, this exponentially increasing processing power, it's been going on for about 130 years, way back to the advent, to the days of mechanical calculators and even pencil and paper. They're getting better at doing these things. So it's not just purely dependent on silicon. It's gone through mechanical, electromechanical, valve, transistor, integrated circuit, very large scale integration circuit. So it's stuck around for a long time. We need about another 30 years, because if you do a rough back on the envelope calculation, the human brain can do about 10 to the 16 operations per second. And your desktop computer's in around the 10 to the 10. So we need about another factor of 1 million or so before they have raw parity.
Don't supercomputers already have parity with human brain roughly?
No.
There's a Japanese weather computer that may.
Yeah. There are probably 1 or 2 computers that have parity. They're not being used to emulate human brains or to do what human brains do.
The biggest challenge is the software part now anyway, isn't it?
Yes, we'll get to that. That's one of the possible impediments. So there are computers now that have comparable processing power to the human brain. They fill up roughly a sort of basketball court, roughly use about $100,000 worth of electricity per hour. That sort of range. But they're not being used for artificial intelligence research. They're being used for sort of weather forecasting, climate modelling, nuclear research, all those sort of number crunching, Fortran-y type things. But it's good in the sense that there is now a proof of concept that we can have that amount of processing power. So I just sort of thought of, from all my reading and research about this, just looking at various things that may be impediments to getting to the technological singularity. Because there's this sort of mystery of, the paradox that there's 100 billion stars in this galaxy, there are billions of galaxies. Why is there no sign of intelligent life? Why hasn't any other planet produced an intelligent life that sort of reached a singularity?
How do we know it hasn't?
Now, it may be that they just choose to be silent and choosing to not let us hear about them, but there is a sort of mystery why no one seems to have achieved that sort of breakup. So, and if you look at our recent history, we've developed nuclear weapons and so on.
We have to be in the light.
We may have dodged a few bullets already, potentially.
Yeah, even if like an advanced civilization reached a singularity, whether they'd be hanging around at this plane,
Yes.
maybe they, I guess, went down really nano or even beyond, as
Yeah.
John Smart would say,
Or femto,
or they,
or whatever.
or femto, as Hugo
Yeah.
likes to say,
Yeah.
or they just went somewhere else that was better. Hung around the middle of galaxies and supermassive black holes. Who knows, right?
Yeah. True.
But in order for us to detect their signals, we'd have to have an intersecting light cone
True.
at this time, which we don't, which might make it even less probable.
So I'm not saying there are no civilizations out there, but it does sort of raise the question of
Where is it?
if civilizations were everywhere, there might be signs of them. So it just
Carl
does.
Sagan used a formula similar
Yes.
to Bayes' theorem to prove that there probably were
Yes.
extraterrestrials out there.
Yeah.
Yeah.
I've seen calculations where people suggest there are probably civilizations out there, but they're probably too far away for us to have observed them yet. They're probably
Why you
a long
still
way.
got that up? I think that earth, fire, air and water were useful for physics. If you
Yeah.
put them in a different order, they represent the phases of solid, liquid, gas and plasma.
Okay. All right. So I think that this slide is really about conceptual confusions
Yeah.
that may delay the singularity. And I've been doing, since I retired, I've been doing a lot of reading about the history of philosophy, going back to the ancient Greeks and so on. And my impression is basically philosophers kind of bring up the rear. Science discovers something and then philosophers explain why they knew this all along or whatever. So, for example, not long before non-Euclidean geometry was found to be actually the true state of the world through Einstein's theory of gravity, we had philosophers saying that Euclidean geometry is actually an a priori synthetic truth. In other words, that it's true about the world even without looking at the world. The whole debate 100 years ago, which very few people are aware about life, there was a big debate about whether living things had an inherent life force or something about them that inherently made living things different from non-organic things. And of course now no one kind of believes that. We know all about molecular biology, etc. So my point about philosophy is that philosophers have, we hear a lot in artificial intelligence and so on about things like qualia, free will, consciousness and so on. But my first question is, how much substance is there to these ideas? And if you look back at the history of philosophy and science, there's not much evidence that these sort of high-level philosophical concepts hold much sway once we actually understand something. So my view about these sort of philosophical arguments that we cannot build an intelligent machine until we understand free will or until we understand consciousness, etc. My view is that these things will be explained once we really understand how to build intelligence and once we have intelligent machines. That's my impression. So I think the net impact of all this is basically likely to be the creation of some confusion, but I don't see anything here in terms of philosophers' ideas and so on that's actually going to slow things down. People are going to build this stuff and then the philosophers will come along, I think, and tell us why it was all they knew this already. Sorry?
Yeah.
If you look at physics, non-Euclidean geometry, the indeterminacy of quantum mechanics, the sort of mixing in of space and time in special relativity, philosophers has anticipated none of this, as far as I can tell. Okay. So who else might want to stop or might slow down the singularity? One of the things that slowed down the Industrial Revolution was James Watt's patent on the steam engine. And because he had mates in Parliament, he actually managed to get that extended to 40 years. So he had a pretty mediocre steam engine, which basically meant nobody else could build a steam engine, and he was raking in the dough, so he didn't really care too much. And it was only when his patents finally expired that things could really kick off. So particularly in biology and in longevity research, the whole thing of patent thickets, that you can't even research something without violating a patent. Someone has a patent on a gene or whatever, Okay, so that's the issue with patents, is that because you have a fixed 20-year term, the speeding up of things is potentially inherently slowed down. It's inherently constrained by this 20-year term. Nothing can happen until we wait 20 years till some set of patents disappear. Now, if you look back at the history of the Roman Empire, one of the things that I think slowed down the technological progress there was that the argument that, look, we have slaves. Why do we need mechanisation? Why do we need technological progress? We have slaves to do all the work.
Another thing is
Yeah.
they were afraid that some technologies might enable their enemies,
Yes.
or the populace to rise up against them. And at one stage, someone actually discovered aluminium and was killed. Was
Yes.
actually was put to death because they thought that aluminium would enable not only their enemies but some competition for them. Yeah.
That's right. So there can be people at the top of a society who don't necessarily want things to move forward, who are happy with how things are. Now, one thing robots could do would be enable wealthy people to get rid of all the people who do all the work. If you have robots to do all the work, why would you need unruly sort of subjects? Why would you need to have sham elections and all this stuff? Sorry? If the robots can do the work. Okay, so that's the. But robots only need to reach a certain point of, sort of menial service. They don't need to get to that super intelligence stage. However, the things that I think tend to make this less likely to be a showstopper is that you've got multiple countries around the world. You've got China and the US and the EU. You might have seen recently the EU's decided to put $1 billion into brain research. The Americans have matched that. There's a sort of this growing sense of competition between China and the US. Barack Obama's putting a lot of focus on Asia now. So competition between countries and competition within the capitalist system, I think, tends to suggest that this is not going to be under control. With the Roman Empire, you had basically one ruler of the whole civilised world. So you've got sort of one guy who can stop progress. Just as with China, a similar thing happened. You had a huge empire, the emperor decided he didn't want this to happen, it didn't happen. But when you've got a multipolar world, you've got a much, only one person has to move things forward and it happens. So my sort of summary is I think patents will slow things down somewhat, as they have always. I read a quote in The Economist, a Chinese manufacturer saying, it's terrible in China, we don't have any patents or intellectual property law that's enforced, and therefore we have to relentlessly innovate and improve our products. Sorry? So you can't get a patent or get a patent armoury and sit on your rest on your laurels. Okay, so short-term economics favours continued research. So the competition of firms leapfrogging each other. I think there's no showstoppers here.
Tim,
Yeah.
the history of patents,
Yeah.
did they predate the Industrial Revolution?
You'll see a patent was basically a license by the king, so you would get a patent to publish books, or it was kind of it started off as just like a license to do something, and it gradually got expanded into modern patent law. But yeah, so they certainly were around at the time of the Industrial Revolution.
Do you know how far back
But they grew, sorry?
Do you know when they originated? How far
Well,
back
they just
go?
kind of, it's like a lot of legal things, they just kind of evolved incrementally. So originally it was just the king would allow someone to manufacture something or whatever, and then the idea of innovation and getting a monopoly because you had sort of innovated.
But all that
came along.
technological progress that did happen as part of the Industrial Revolution
Yeah,
probably really saw the growth of patents. That was a real
absolutely exploded,
catalyst
yes.
to-
And it's sort of, patents have exploded exponentially. There's more patents every year now than there were before the 20th century at all. So it's huge. Arguably, a lot of the patents are quite trivial though. 99% of patents never generate any revenue and are never put into any product. So, yeah, but it was probably the Industrial Revolution, 18th and 19th century, really kicked off.
I'm pretty sure that patents were first used by like the English royal, like the Queen would have created patents to kind of to give favours to power groups.
Absolutely, I mean, you would be the only person. It's like in, I mean, a classic example is the license Raj in India. You know that you are the only firm who are allowed to say manufacture salt, or you are the only, like Mahatma Gandhi went down to the ocean and made salt as a sort of symbolic protest against this sort of monopoly. So that was, yeah, right. That's the kind of thing.
I think another incentive for it was also to try and keep out like competitors from outside of England. But I mean, like then when America was started, they kind of thought about what had been used in the past and actually, you know, decided reluctantly on some of the parts of the founders apparently to, you know, use some of those principles.
That's right, because it says in the Constitution for a limited term.
Which is not really applicable anymore.
Patents were to be owned for a limited term, and similarly copyrights were to be a limited term. But they extend the copyrights by 20 years every year, so... All right. Zots, okay, so this might be a bit more controversial. In the past we've seen religious takeovers that have suppressed progress. You know, the most infamous example is the Catholic Church banning the teaching of mathematics in 1100 AD. You know, the sad situation that the world knew less about mathematics at that point than it knew 1600 years earlier. So the average monastery had 3 books. There is a sort of image that the knowledge and learning was retained, and some was. Aristotle's rhetoric and some aspects of Aristotle's work was preserved by the church, but in general, or often religions will slow things down, and again by creating a monoculture, by having one truth that cannot be challenged. As Nassim Taleb said, you know, dissent is information. If you cannot have dissent, you're losing that information. Okay. So, if you look at the demographic momentum in Western societies, religious people tend to have far more children than non-religious people. So we're sort of up against that in the sense that, you know, you're seeing in the US, in the long term, it looks like we're going to have a shift back to the religious right. So that's the kind of risk there, that we get and you have the same issue, a big issue in Israel, for example, with the Orthodox Jews having families of 8 or 9 or whatever, versus the liberal Jews having 1 or 0 children.
The US also has a very large military sector which is trying to advance technology as fast as possible.
Yes, that is true. So it's quite unpredictable how this will all pan out. But you know, if you look at history, religion has been often associated with periods of stagnation of many years. So there is a risk there, and the demographic issues may potentially make this more likely. Okay, so this is more much comedy as anything, but I'm just using this the thing about gender Marxists as an example where a lot of interests will be threatened by robots.
The feminist ban was actually a hoax.
Well, I've
Just Google it now.
sorry?
Yeah, so just Google it now.
All right, okay, all right. Okay, all right. So the point does remain that artificial wombs and sex bots do pose a threat to female sexual monopoly on sexuality and reproduction. So there's potentially an issue there. Now, I would point out that it's possible even that the majority of sexual acts actually, even now, occur in the absence of an actual live human partner. And, you know, we're talking about internet pornography, etc. So, The thing I think that will make this completely moot is that there's a lot of money to be made. You know, you look at, say, the pornography industry has just swept all before it simply because of the amount of money involved. And when large amounts of money are to be made, that creates huge incentives for people to make it happen.
That was a theme.
Yeah.
And I don't want to
Yeah.
this theme because it's really tricky.
Yeah, yeah.
But that recent sci-fi book, Wind Up Girl,
Oh, I don't
Hmm.
know. Yeah.
Yeah.
you know, worth reading. As a
I think he won an award at the last AussieCon.
Hugo.
AussieCon. Yeah.
Hugo and Nebula Award.
Yeah.
Yeah.
So, you know, it's one of the top sci-fi books of the recent last few years.
Yeah.
Yeah. Okay.
It strikes me that the most dangerous way in which these tensions manifest is in conflicts between countries on the survival of ecological issues, because, you know, like within a country, the incentive to make money is probably going to outweigh the power of any one group that is concerned about what robots can do. But if you've got kind of whole cultures that differ significantly in where they think we should take technology, then that could lead to much more dangerous types of conflicts, including nuclear. You know, it's
Yes, that's true. So the whole issue around war, and particularly once, you know, if you have, say, Cromwellian England or whatever, you know, religious theocracy trying to impose their will on the rest of the world, for example. You know, and in that environment, you know, market forces don't really play a role.
because market forces can't really stop wars between countries.
No.
Well, I mean, they have incentives that do. I mean, you know, like America and China don't want to fight war because of the economic costs, but.
But I mean, before World War I, it was argued that a major war was now inconceivable because the economic costs would be just too high that no one would put up with it, because we had not one but two major wars. Okay. Okay, so collapse, I think, is one of the most serious issues. You look at all the things that are going wrong in our society or that we're facing, you know, the exhaustion of energy sources, pollution, decreasing yields in all sort of minerals and so forth. You know, we're having to dig deeper to get coal. I think a good gold mine now is 3 parts per million gold. You can have an economic gold mine with 3 parts per million. That's how, and similar issues have occurred with copper and all sorts of other minerals as well. So, water shortages, food shortages and population growth. And the thing about all these things is they all make each other worse. For example, food shortages are made worse by the lack of cheap energy. If you take away cheap energy, Australian agriculture collapses because Australian agriculture needs cheap fuel to run tractors, to plough vast areas of land, and it needs cheap energy to make fertilisers, which are very energy intensive. So that's just one example, but you look at all the water shortages make food shortages worse. Population growth makes you know, all of the above worse, etc. So you know, if you sort of do some crude projections, and you know, in 50 to 100 years, our society is going to run into some serious brick walls. So the way I see this is that if the singularity comes along, all good, but if it doesn't, we face these sort of issues. You know, running out of oil, pollution, carbon pollution, etc., getting worse and worse. A lot of the water supply the world uses is actually mined water. It's a finite supply, the Great Artesian Basin in Australia, similar in the Middle East, etc., etc. A lot of so-called renewable energy sources are not really renewable. You know, hydropower, for example, is not really renewable. It's a finite resource. You build the dam, it fills up with silt. No more dam. Okay. And we talked a bit before about theocracy and you know, ideological monocultures, etc. So what does this do to you? Number one, it stops information from happening. It stops research from happening. It stops information from flowing. It stops people learning stuff. So this is a big threat. But again, only if it occurs on a worldwide scale. Now I can remember when I was a kid in the 60s, there was a lot of concern about nuclear weapons. And this is when America and Russia had nuclear weapons. Now I don't know how many countries have got nuclear weapons. Let's see, we've got China, Russia, America, England, France, Pakistan, Israel, India, and quite a few other countries sort of on the cusp. So the threat of nuclear war is greater, I think, in some ways than ever. We've got waning American power, and China's growing, and historically these sort of changeovers of the leading power have tended to result in a very unstable situation as the old power tries to hold on to power and the new upstart tries to assert itself. So, again, we talked before about how if you have countries that are, theocracies or are run by some ideological group, this greatly increases the risk as well. Okay. So, in terms of the collapse thing, this is potentially one argument, one explanation of the Fermi paradox. Why haven't we seen any civilization? Maybe everybody faces this problem. They build a civilization, they're smart enough to build a civilization, they're smart enough to deplete the resources, and they do that, pollute themselves out of existence and back to the Stone Age. I think the only thing that will save us from theocracies and ideological dictatorships is that it has to be worldwide. And again, I think war is actually a big threat, a very big threat. So out of that we've got the ecological collapse, which is a race, and war. Okay.
Ecological collapse
Yes.
is also the plot in the wind-up board. It's the
Oh,
main-
really?
It's the main
Okay.
plot. It's in the near future.
There's quite a few. I'll send some links there. There's quite a few books on Amazon on that. Where people go into a lot of detail about. Let's look at our world situation and model it, etc. I mean, there was the Club of Rome back in the 70s. I went back and actually read the book. It's actually quite good, and its predictions have held quite well. Some of the alarmist discussion that came out of that was overblown, but they've just recently done, I think, a 30-year update or a 40-year update, and it's well worth reading. Okay. Now back in the Industrial Revolution, we had the Luddites smashing spinning machines and so forth. Now, economists tend to go back and look at, machines came in, they displaced people, tractors came in, they displaced people, people went to the city and started working in factories and all was well. We're all better off. But I think it appears with the technological singularity, once you have intelligent machines, it's a different ballgame completely. Since the last recession in the US, Australia's a slightly unusual situation because we've been the raw material supplier to China. So we've been shielded from the problems that are happening in Europe, the US, etc. But if you look at the US, 105% of the jobs created since the last recession have been good jobs.
Can you explain that 105% figure? What's the...
Well, that means is the jobs that have been not garbage jobs have actually gone down. So in other words, say 100,000 jobs have been created, right? 105,000 jobs and minus 5,000 good jobs. So this whole issue of the middle class just disappearing. And you see every recession, employment, unemployment, and the duration of unemployment is getting worse and worse. So economists are very sanguine about this, but I'm not. At some point people will realise the implications of this, that basically everyone's going to become a welfare dependent. Just about everyone's going to be out of a job, is going to be not worth employing. The thing is that in terms of stopping the singularity, I don't think it's going to happen. Trade unions have tried to oppose this sort of thing all along and they've never gotten anywhere. And again, the economic incentives of each individual company to replace workers with robots are enormous. Even in China now they're replacing workers in factories with robots. Because it's not just a matter of cost, it's a matter of quality, reliability, flexibility, etc. You put in a new system into your robots and overnight it all happens. So I don't see these things. There'll be potentially a lot of angst, a lot of turmoil, but I don't see any of these things stopping the singularity. So, in summary, this is my opinion, but I think the main impediments to a singularity is that actually we don't get to singularity soon enough and our technological civilization collapses, or there's some sort of war between China and America. I think those are two things. But I'd be interested to just open up the floor and see what people think, or if anyone has any other thoughts on what might get in the way.
Technological difficulty or impossibility. Moore's law runs out of puff.
Yeah. We've sort of covered that in past, but as I said, like Moore's law's been going for 120, 130 years. We only need another 20 or 30 years. We can already see a roadmap 10 years out. And even if it slows down, the other thing is we have a proof of concept in the brain. The brain can do that amount of processing, so we know atoms can do that sort of thing. So that's what was the other? Oh, just the difficulty. Oh, someone mentioned software. The difficulty, like, okay, we have the raw MIPS, but can we write the software? We don't understand qualia, or we don't understand whatever. If you look at the history of computer science, very consistently, the software guys have been ahead of the hardware guys, waiting for the hardware to show up. And when you think,
like the case anymore, though.
Sorry?
That doesn't seem to be the case anymore, as in this particular issue.
Well, your desktop computer is still probably a factor of 10,000 under the human brain. It's probably got the equivalent processing power of approximately a tenth of a cc of your brain. So we've still got a huge hardware constraint, and hardware constraints work in two ways. 100 billion neurons, 1,000 connections. The connections are actually the active processing units. It's now been shown. The cycle time's about 10 milliseconds, so you multiply that out and get 10 to the 16. And there's no desktop computers anywhere near that.
But we have like things that we can do that just tiny sub-modules of the brain are responsible for. And even with massive supercomputers, we still can't do like, certain kinds of pattern recognition that human 3-year-olds can do.
Well, yes, but if you look at the human brain, about 25% of it is vision processing. So vision is very computationally expensive. Very computationally expensive. The hardware gap creates two problems. One is that you actually don't have the gear to run the algorithms. And the other thing is, it's very difficult to actually debug and develop the algorithms without the hardware. If you've got a 1 million instruction per second computer, and you're trying to develop an algorithm for a computer that's, say, 10 to the 10 times as fast as that, it's going to take a long time to run simulations. So, in a sense, we have, until the hardware's around, it's going to be very hard to really fine-tune and debug those algorithms. So, when I started at NAB, we had the processing power in the bank altogether of approximately one cockroach brain. And we were running millions of bank accounts, all sorts of, credit scoring, all sorts of stuff, just with an absolutely minuscule amount of processing power. So there are, it's not all, there are some issues, things we don't understand, but having watched this since the 70s, when the hardware becomes available, generally I've seen that the software is caught up very, very quickly. You look at, sorry?
You can try more algorithms in less time then, so it's
That's
But
right.
here's the
You can
thing.
debug things more quickly. You can run more algorithms that are thought of years ago. I mean, a lot of say when Windows 3.1 came out and graphical user interfaces, a lot of that stuff had been developed 15, 20 years earlier. But
Douglas Engelbart.
Sorry?
Douglas
Yeah.
Engelbart, who recently died, had a lot to say about that.
Yes.
In the 60s.
That's right. Now, I mean, not to say there haven't been errors made. I mean, you know, in the early AI research, they assumed that artificial intelligence would be achieved through symbolic logic, which turned out to be a wrong approach. But in their defence, when you've got a machine that can only do 100,000 instructions a second, you can't. Symbolic logic is one of the few algorithms you can actually run. So, you know, in a sense, they were looking under the light post because that was the only place they could see. Yeah.
Do you need consciousness to have artificial intelligence? Is it prerequisite?
Oh,
No.
that was part of the start of the
Yeah.
Just I agree.
Yeah,
Yeah.
Yeah, I think it's a sort of side issue in that if you look at, say, physics, do you need to understand wetness to understand molecular, molecules and chemistry? When you understand, hardness or shininess or whatever, they're not the keys to understanding things. They're things that you understand once you really understand what's going on. And I think, in my opinion, consciousness will be one of those things that once we really understand the brain, we'll understand consciousness.
No, they still don't understand atoms though, right? I mean, turbulent flow is still...
We don't understand what, sorry?
Wetness.
Wetness.
We can't predict
Qualia, that's fine.
we can't predict the behaviour of liquids in full detail. That's very true.
But we only have to predict them enough to, for our predictions to be useful.
Yes.
We don't need to predict everything about it to be useful. We can functionally make representations of if consciousness needed, then consciousness. Even though we may not understand the entire physics behind it, we can still do stuff with it.
And at a pretty good level, we understand why surface tension exists. We understand why turbulence exists in fluids. So, there's no analytical solution to the Napier-Stokes equation.
I think we're still pretty bad at very large, complex software systems and putting them together.
Yes.
The approach has been in the past, you develop something over here, you develop something over here,
Yeah.
you get it together and it causes gross instability
Yes.
and lots of bugs. And in fact, Denver Airport was delayed 6 months by
Yes.
software problems,
Yes.
opening, an enormously expensive thing. In the future, we will have to have integration from the beginning, I think, in our software development.
This is an interesting point because always in AI, there was always this idea we will code up the AI machine, we will code up the robot. And over the last 10 to 15 years, they've moved to a sort of different paradigm where basically you build the software that enables the machine to learn. And so therefore you don't have to necessarily detailed, code every, the Google car, they don't even code, if there's a line with white dashes, then that probably means that, it's a lane thing. They do higher level algorithms that enable the machine to learn, so you don't have to program everything in detail. The brain's physical structure is incredibly repetitious. There isn't the amount of information in the genome to code all our, our brain must be a thing that just, you point at the world and it understands, it kind of works it out, it learns. So that seems to be a much more successful approach with AI than actually having 5,000 programmers trying to sort of individually code facial recognition or whatever.
Yeah, I agree.
So that sort of software bottleneck, I think that is probably the best answer to that. If you've had kids, you don't teach your kids hardly anything. They learn.
So Tim, what do you expect to see? What sorts of discoveries, what sort of research thresholds, what sorts of engineering feats do you expect to see that will increase your assessment of the likelihood of a singularity coming on?
So it's just really about tracking the pace of it. Does Moore's law slow down? It's interesting actually talking to people, taxi drivers, etc. That now you actually do have quite a few things where you can point to people, the Google car and different things where you can point people to them and say, look, here's an example of the kind of thing take the Google car forward another 10 years or whatever, what does that mean for taxi drivers? What does that mean for bus drivers, for truck drivers, train drivers, etc.? So there is starting to sort of percolate into consciousness of people. It no longer seems like such a mad idea that it did even 5 years ago. Yeah.
You got those, yours.
Alright, I wanted to just throw two bits of Steven Pinker at you. One is a comment and the second one is a question. But obviously, one of your key pessimisms is about war, and I was going to suggest that he has some pretty good arguments as to why maybe war isn't as likely to be a problem as we may think it is. That there's always the potential issue of just massive accidental nuclear catastrophe, for example, that isn't caused by the social and political factors. But you may have already come across his quote where he says, sheer processing power is not a pixie dust that magically solves all problems. And this is his scepticism about singularity. And certainly we know that when we have lots of intelligence, in a good way, to some extent, we get a lot of friction and debate and disagreement. That's how human intelligence operates. So it generates politics. So my question to you is a general one, and maybe it would be the next slide if the talk continues. What sorts of problems do you expect a singularity to address or solve? And what sorts of problems would a singularity leave untouched, and what kinds of things would remain as they are, potentially?
Well, I suppose it's inherently unpredictable, kind of by definition. I mean, my hope would be that we can kind of go along for the ride, rather than have the machines run away from us and leave us behind, that we can sort of plug ourselves into the machines and become enhanced super intelligences ourselves.
I mean, like with I guess, you know, any complex problem can be sort of, I guess, more efficiently addressed with more intelligence looking at it. It's not like intelligence is going to solve the problem if it doesn't find the solution, but having more intelligence will help find the solution, even if it's brute force. But if it's pure creative intelligence, it's able to, I guess, scan more of the landscape of possibility than our narrow brains can, then maybe solutions to global warming, costs of fuel, better substrates to exist on will become obvious to a singularity.
Sure.
And I think one of the most promising things is in terms of life extension and understanding biology, because our biology is a sort of mess and it's incredibly complicated. My daughter's doing PhD in molecular biology, and she's just working out this one little tiny confetti piece of the total picture of how malaria works. So, if you could apply vast intelligence to that, you could, I think, get to an understanding of a lot of these issues a lot quicker.
Maybe the implication that I was drawing out was an earlier slide with a whole set of defeaters on it for a singularity. Is the implication that post-singularity, those defeaters will have been defeated? Is the singularity something that addresses all of those things?
Well, they will have been either sidestepped or what if it not have occurred or whatever. So, for example, say ecological collapse. Assuming superintelligence comes along before that happens, then that gives us potentially the opportunity to deal with these issues in a much more sophisticated and effective way. For example, what if we could make solar power much more effective? What if we could, get the energy from the sun? All that sort of thing.
I think the answer goes a bit deeper than that. Tim talked about it a moment ago. The almost implicit in the definition of singularity is that things become unpredictable in principle. And so tied up in the notion, the concept of singularity is that everything is so different so quickly that trying to frame questions in terms of what the issues are now and how they get solved probably doesn't make sense.
Well, it doesn't make sense if you're using the singularity in like the literal sort of Vingian sense. But often when people say singularity, they actually mean intelligence explosion, which doesn't preclude there being like an obfuscation of the future caused by the intelligence explosion or accelerating returns leading up to it. If you just,
So Adam and I were talking about that before. There's actually different working concepts
That's
of
right.
what singularity means these days.
4 major ones, and the singularity is one of them. Intelligence explosion is probably the most Occam's razor version. The accelerating returns is very heavily focused on continued growth with technology, and there's the augmentation of humans as well, which hasn't been discussed. Human intelligence.
So I was trying to focus on what would prevent us from getting to that point, but it's a very interesting discussion. You know, what would it look like if we get there and all that sort of thing. Someone should perhaps talk
Well,
about
I think
that.
there's a couple of scenarios. One is that superintelligence may make us very much more aware of like conservation and resources and so forth, and treating our planet well. The other sort of side of the coin is that sooner or later we'll have implants which enable us to transmit thoughts and talk to each other through thoughts. And then along comes some horrible bugger who wants to network us all into military puppets. And that's a very dangerous scenario. So we've got to sort of work along other lines, I think, as well as the technological angle.
Yeah,
I think Jeff's going to talk about that.
What time is it? What time? Have you really got the time?
20 to 8.
20 to 8.
Okay,
Okay.
better call it quits
So
then.
let's-
Thank you very much.
Yeah, thanks. Let's thank Tim for his wonderful presentation, his efforts, all the way down from the Blue Mountains.